Hello everyone, welcome back to our channel. So today we are going to try to prove that a central angle is a double of inscribed or circumference angle standing on same arc. So to prove this theorem, first let's make a circle. Okay, so here we have our circle. Now let's assume that the center of the circle is over here. Okay, so now we have our circle. We need to make a central angle and an inscribed angle on the same arc in this circle. So let's choose our arc, okay? Let's say our arc is from here up to here. Let's name this arc EB. Our center is our O, right? Now to make a central angle, we just need to connect this center from our arc, okay? So here and then from here up to our B. So this angle right here is our central angle, okay? Angle AOB. It is standing on the arc AB. Now what we need to do is we need to make an inscribed angle or circumference angle on the same arc AB, okay? So we can do that by drawing a line from this point A, okay, up to the circumference. And let's make another line, okay, from B, and let's join these two lines. Now this point is touching the circumference, right? Let's name this point C. And this angle right here, okay, is our circumference angle because it's touching the circumference and it is standing on the same arc AB. So now we have AOB our central angle and angle ACB our circumference angle standing on the same arc. Now what the theorem tells us is that this central angle AOB is double of this inscribed angle or circumference angle ACB. So for example, if this angle was 10 degrees, right, this angle would be 20 degrees. It would just be double of this inscribed angle. So if it was 110, this would be 220 degrees. That's what our theorem is telling us. So if this angle was x, then this angle would be 2x, okay? So we need to prove that this central angle is double of this inscribed angle. Okay, so I'll just erase those example things. So to prove this theorem, we need to make a construction. We need to draw a line from this C in such a way that it connects with our O, okay? So it's connecting with our O. Let's name this line CD, okay? So we make a line CD passing through the center of the circle, O. Now, the way we are going to prove this theorem is we are going to assume this angle as, let's say, A, and this angle as, let's say, B, okay? Now, if we can prove that this angle over here, right, is 2A and 2B, right, then our theorem is proved, okay? So this entire angle would be A plus B, right? And then this entire angle would be 2A plus 2B, which would be equal to 2 bracket A plus B. And if we can do this, then we will know that this central angle 2 bracket A plus B is double of this inscribed angle A plus B. Now, how can we make this angle and this angle 2A and 2B, right? So if we can do that, our theorem is already proved. We can do this by using the theorem of isosceles triangle, okay? So this is the radius of the circle, right? It's from O to C. This is also the radius of the circle. It's from O to A. And these two lines are equal because they are both radius of the same circle. So this triangle right here, AOC, is an isosceles triangle. And since this triangle is an isosceles triangle, its base angles are equal. So if this angle is A, right, then this angle will also be A because the base angles of isosceles triangles are equal. Similarly, if we look at this right triangle, again, OC is our radius and OB is also our radius, right? So if this angle is B, then this angle should also be B because, again, the base angles of isosceles triangles are equal. So we have this angle is A and this angle is also A. With this angle B, we have this angle also B. Now, this angle right here, right? This angle right here is the sum of this angle and this angle. Why? Again, it's because of the theorem of our triangle, okay? The sum of two non-adjacent interior angles of a triangle is equal to the exterior angle produced by one of its side, okay? So if we look at a triangle, okay, let's look at a triangle. then this angle, exterior angle, is equal to the sum of this angle and this angle, okay? This one and this one, the non-adjacent angles. Similarly, in our triangle, we have this angle as A, this angle as A. So this angle is going to be A plus A, which is 2A. And we can do the same in our right triangle as well, right? So B plus B is going to be 2B. This exterior angle is equal to 2B. And if this angle is 2A and this angle is 2B, we can write that as 2A plus 2B, right? This entire angle, and we will be able to prove our theorem, okay? Now let's write all of this in a little bit formal way, okay? So we have our solution, and then we have our given. So first, we know that O is the center of the circle, right? This is given. And angle AOB and angle ACB, our AOB and our ACB are central and inscribed angles standing on same arc AB, are central and inscribed angles made on same arc AB. So this is our given. Our next step is to prove, right? So what we need to prove in this theorem is angle AOB, our central angle, is a double of our inscribed angle, angle ACB. Okay? So we also made a construction in this question, right? So our construction, we made a line CD passing through O, okay? So we are going to write that in our construction. Draw CD passing through O. Now our final part is our actual proof, okay? So we have our proof. In our proof, again, we are going to have statements and reasons. So now in our proof, we are just going to write everything that we discussed before a little bit formally, okay? So we are going to start from this A is equal to this A, okay? So now number 1, we have angle OCA is equal to angle OAC. Why? Because the base angles of isosceles triangle are equal, right? So base angles of isosceles triangle, okay? I'm just using short forms here. So these two angles are equal. Our second statement is going to be A plus A is 2A, right? So angle OCA plus angle OAC, when we add these two angles, it should give us angle, this exterior angle, okay? AOD. AOD. The reason is sum of non-adjacent interior angles, sum of non-adjacent interior angles is equal to the exterior angle, okay? So we have our this angle OAC plus this angle OCA is equal to AOD. In our number 3, what we can say is, since this OCA and OAC are equal, we can replace this OAC with angle OCA, right? From our statement 1, and we can write that as 2 angle OCA is equal to angle AOD. Okay, so this is from our statement 1 and 2. So in our number 3, we are going to write from statement 1 and 2. So similarly, in our number 4, now what we can write is 2 times angle OCB is equal to BOD, okay? So 2 times of this angle B, okay? So OCB is going to be this angle, right? BOD, it's 2B. So the reason is going to be same as above, okay? So we are not going to repeat all those steps again. Now in number 5, what we are going to do is we are going to add these two statements, okay? Number 3 and number 4. When we add that, we'll get 2 angle OCA plus 2 angle OCB is equal to angle AOD plus angle BOD. So this is by adding statement 3 and 4, right? So by adding statement 3 and 4. Or we can write this as, if we take 2 common, we get angle OCA plus angle OCB is equal to angle AOD plus angle BOD, right? So I'm just taking 2 common here. Now in our number 6, what we can do is we have our 2 over here, angle OCA plus OCB, okay? Angle OCA is our this A angle, right? And angle OCB is our this angle B, okay? So when we add these 2 angles, we get this entire angle, angle ACB. So 2 times angle ACB is equal to AOD plus BOD is, AOD is our this angle right here. Our BOD is this angle right here. When we add these 2 angles, we get this entire angle, angle AOB. So angle AOB. The reason for this is when you join these smaller parts, we get the whole part, right? So we can write the reason as whole parts axiom. And we can also write this as, right, we can just flip that and we get angle AOB is equal to 2 times angle ACB. And done. We have proved our theorem. So we needed to prove that the central angle AOB is double of our inscribed angle ACB. And that's what we have done. So if you enjoyed our video, please give us a thumbs up and subscribe to our channel for future maths videos. Thank you.